We shape thinkers and self learners, making knowledge an exciting journey. Opening new doors and steering into new horizons, our students are a generation of tomorrow, a timeless tribe of change makers. When the fire burns within them, we rouse it to scale greater heights. When ideas germinate, we support our students to become entrepreneurs and help them cultivate it to bring about revolutions of change. At RKU, they are the nucleus, surrounded by a circle of learning, nurtured by hands of knowledge. By giving them a global exposure, we allow understanding to seep through project-based learning. They get their hands dirty, assess real situations, unfold new theories in our labs, and find holistic answers to every hurdle that comes their way. Interweaving happiness and learning, the university provides a vibrant atmosphere to fashion well-rounded personalities who are people of thought, people of freedom. Powered by spirit of inquiry, they move into the world on wise words and firm foundations. Each day, they pave a path that arches forward for themselves and those that will follow. At RKU, we make worlds meet. We craft trailblazers who shape better futures. We look forward together, standing firm on today's lessons and the possibilities of tomorrow. For the world is not our oyster, the universe is.
Hello everyone, myself Dr. Jayesh Dhalani and I am welcoming you all uh, in webinar series of chromatography and electrochemistry. So in this webinar series we observed very huge participation on national and international level. So yeah, what will you gain after this webinar? you can get the answer of selection of proper techniques of chromatography after attending this webinar. So one more important instruction, please write your name in chat box for attendance purpose so we can take your attendance. Now we are going towards the session. Today I will deliver the session on chromatography and with their advances and applications. And tomorrow we have a session of Dr. Bhavin Dhaduk. We will send you the separate link on your mobile and on your email addresses. So we are going towards the session. You will get the surely about knowledge of chromatography, practical approach of chromatography. We have a focus, very less focus on theoretical aspect. We are giving you the practical aspect. And see all the chromatographic techniques, particularly at we can deliver the 5 to 6 sessions on each topic, but here we have keep the overview of all session. So we are going toward the session chromatography with advancement and applications. You can write me your query at jayesh.dhalani@rku.ac.in, and you can also call me on a given mobile number. You can also take mobile number from my email address. You can also write your query in chat box, and Dr. Mayank Pandya will answer your query in chat box. So first of all, what is chromatography? This is the physical method of separation. You all know that, and very basic things. Pure substances from mixture. You will get the pure substance from mixture, and you can apply these techniques at micro level. So this is the very good advantage of this technique, and chromatography and their advancement you can use at micro level. Who invented? Russian botanist Sweat in 1906 invented this technique for isolation of phytocompound. So basically this technique was used for isolation of phytochemical compound with use of column chromatography. In that calcium carbonate was used. How it differentiate other separation technique? See, there are many separation techniques are available: distillation, extraction, crystallization, sublimation, filtration. But what is the advantage of chromatography? So there are many chance to get the impure compound in the other techniques, but in chromatography you can get the pure compound as compared to other techniques. The problem number two, there are many chance of getting the similar functional group compound, but in chromatography you can separate the pure and single spot compound. Problem number three, time consuming. Compared to other technique, the chromatography is very less time consuming, and you can also identify the compound which cannot possible in the other techniques. Principle: chromatography is a physical method of separation in which components in a mixture is separated based on different migration rate or different partition coefficient that can be possible by using two phases. One is stationary phase and second is mobile phase. See, this is the principle, and I think you all know this principle, but I want to give you the very basic example of this chromatography. Just imagine one car race. We are going to arrange one car race. So the which there are a list of brands available in the car, and which car will get the first position. Just imagine. So the very basic things are uh, you can assume that from first thing to be in the car race is required is the fuel. Second thing, high speed. So and third thing, good driver. So reach out at the first position. You require high speed, good driver, and fuel. So compare these all things with the chromatography definition. different migration rate and different partition coefficient, that means the speed of car. And fuel means combination of stationary phase and mobile phase. And third thing, the driver means we are who is the doing the experiment in the lab. So you can easily compare these all things in the chromatography definition or principle. Now you can see here the mechanism. This is the mixture of A plus B compound. Now you can see the B compound is eluting first. It means B compound will come first and A will come later. So the separation of compound between stationary phase and mobile phase you can see. Classification on based on nature. You can see here the stationary phase and mobile phase. Physical state of stationary phase and mobile phase. By this combination, different classification of chromatography technique we can see. Stationary phase solid and mobile phase is liquid. So liquid solid chromatography. And then stationary phase is solid and mobile phase is gas, means gas solid chromatography. This is the adsorption chromatography. On the basis of nature, stationary phase liquid but coated on solid. So and mobile phase is liquid. So this type is called liquid chromatography. In other, stationary phase is liquid coated on solid and mobile phase is gas, then that is called partition chromatography. Now we are going towards the different techniques, that is TLC, column chromatography, HPLC and GC. Thin layer chromatography. In normal phase TLC, your stationary phase is polar, and that is mostly we are using silica. And on silica surface there is a selenol group present. That's why it's behave like a polar. And mobile phase is non-polar, means comparatively non-polar, and we are using the binary solvents in that thin layer chromatography experiment. Binary solvent means we are using the two solvents or more than two solvents. Sometimes we can use the up to 4 solvent. So the in the separation you can see here the center is the polarity. In every experiments of chromatography, polarity is the center thing. How it can progress? So you can find here that there is step 1. So step 1 you can see here the we have to cut down the TLC, and all you can prepare in the lab. Second step, you can draw the line, and this is called step 2. And step 3, here we have put the compound A and B, and mixture of compound A and B. So A and B compound is present in the mixture M. Now step 4 is the chamber saturation. Chamber saturation is the very important thing in thin layer chromatography. If you have not saturated the chamber, you will not get the better result or better separation. So for chamber saturation, approximately 15 to 20 minutes are required for proper saturation. Now we are putting the TLC in the chamber, and you can see here the development of chromatography. So A compound is showing the spot, B compound is showing the spot, but you can compare the RF value of B compound with compound present in M. So by this you can say that the B compound is present in mixture M. Same thing is with A track. You can say that A compound spot is present in M. Many compound we can see in the daylight, but it happen sometimes we can when the compounds are colorless, at that time we cannot see in the daylight. So at that time you can see in the UV chamber, and you can find the spots on TLC plate. So there are other ways also to visualize the spot. You can spray the visualizing agent and you can visualize the spot. Here we have put the example of iodine chamber. You can put the TLC, develop the TLC into the iodine chamber and you can get the spot. There are many types of visualizing agents are available. For suppose for sterol there is a Lieberman-Bouchard reagent, for amino acid ninhydrin. So there are many visualizing agent for particular group identification. So you can select that visualizing agent for identification purpose. Now you can see on the screen we have put the three spot, and you can see the after development of spot there is a three spot on and one spot on each track. So how we can calculate the RF value means retention factor. So the distance traveled by solute upon distance traveled by solvent. So here you can see this is the solvent front and C is the solvent front and the A is the distance traveled by solute. So A upon C and you can get the value RF value. Solvent system designing. You can see here the TLC development is very easy task because you also know when you are performing the practical in the chemistry lab, at that time the faculties are giving you the ready-made solvent system and you are just putting the spot and developing the TLC and then you are visualizing the spot. At that time you are getting the ready-made solvent system, but when you have unknown mixture and how to develop that mobile phase means solvent system, how to identify the particular solvent system, it is more important in the chromatography separation. There are several ways to identify the solvent system, but trial and error is the necessary requirement to develop the or achieve the good separation. So we are starting from the literature review. If you know the mixture is the phytochemical compound or particular group of compound like sterols, flavonoids, glycosides, sugars. So you can find the proper system from literature review. You can just identify the mixture of solvent and you can tune that solvent system to achieve the good separation. So this is the one way is literature review, but in that case you have to perform the trial and error. Okay, so in solvent system miscible properties is highly required, otherwise your solvent system will not generate and you cannot get the separation. So two or more solvent combination with miscible properties is required. See, I am again telling you that there is no thumb rule for design any solvent system. You can do the practical work and you can design that solvent system for particular mixture or particular group of compound. So the many students are asking, sir, where should we start from the to design the solvent system? So if you don't know anything regarding your compound, so at that time you can start from hexane ethyl acetate solvent system. So many organic chemists are using this solvent system in the purpose of reaction monitoring and any single spot compound or any purity checking. Different visualizing agents. See here the group of compound and spray. Step for sterol, Lieberman-Bouchard reagents. For sugars, methanol sulfuric acid, flavonoids, 5% FeCl3, alkaloids, Wagentroff reagents, amino acid, ninhydrin, and antioxidant compound, that is DPPH spray. Now I forgot to say that in solvent system designing, most of you have done the practical of amino acid on the paper chromatography. You all have used the system of butanol, water and glacial acetic acid. This system is very common. So you can find by literature review of any group of compound and you can visualize the spots and you can separate the group of compound. Now you can see the TLC developed by my students. You can find the extract separation very good in the TLC. This is the students. This TLC is developed by my students, and for natural product compound, you can achieve the very good separation after so many trials. And on the right side, you can see these images with high resolution. You can also observe this good separation, very good separation observed. You can see here. So this is the automated TLC result. Means there is an advancement of TLC is called high performance thin layer chromatography. So it is called HPTLC analysis. So here you can see the automatic TLC sampler. So you can spot automatically. You can generate develop the chromatogram. You can do the densitometric evolution, and you can image. You can document particular image as early slide. You can see, and VisionCat software is used in the HPTLC instrument of ChemApp. Now you can see the results of HPTLC, like very high resolution, and that this type of result we cannot achieve by simple TLC. You can see here the single spot compound, and we can get the chromatogram like this. And in the mixture of compound, these all are mixture, and in mixture we can get the multiple spot on one track. So this is the chromatogram we can get after the HPTLC analysis. Here we can say that this is single spot compound is reference, work as a reference, and this yellow compound is, you can see here, the yellow compound is present in all the tracks. So you can see very clearly, but we have to provide the proof of compound is presented in this whole mixture. So that proof we can get in the HPTLC analysis. This is the superimposed spectra you can get in the HPTLC analysis. You can see here this single spot compound is present in mixture. So by comparing this both RF value, you can get this this superimposed spectra. You can say that this both compound are same, and reference standard compound is present in the mixture. So that is not possible in the TLC only. Now we are going towards the application. So mostly you are developing the TLC, you are developing the solvent system, and you are achieving the very good separation. But if you scale up your experiment, if you scale up your TLC, so you can make the preparative TLC that you can prepare in lab on the glass plate. And if your compound is impure, suppose your compound has two spot, and one is impurity and one is your compound, so you can cut down, you can develop the TLC, and you can cut down the band, and you can recover the pure compound from that band. So that experiment is called preparative TLC. Now we are going towards the applications of TLC. So main thing is check purity of compound. If you are getting the single spot compound on TLC, then what? The compound is pure. If you are getting the more than one spot in for the compound, then you have a mixture or you have a impure compound. To know mixture of compound, yes, how many compounds are present in your mixture. Next is the to identify group of compound present in mixture. I have already shown you in the previous slide. There are many, there are several visualizing agents are available to identify the group of compound. You can make that, you can develop the TLC, and you can use the visualizing agent, and you can identify the group of compound. To identify the compound with RF value, In the TLC experiment, I show you the A compound is present in the mixture by comparing the RF value. So you can identify the on TLC that this compound is present in my mixture. But condition is that you have the reference or any standard compound. One more application is that you can monitor the organic synthesis reactions. You can put the reactant spot and product spot, and you can show on the TLC the product, how much product is converted, reactant is converted into the product. So you can monitor the reaction on TLC. Now we are going towards the HPTLC. Perform all application of TLC with high resolution. Whatever the application you can perform in TLC, that all application you can perform in the HPTLC instrument. Next is the quantitative analysis. You cannot perform the quantitative analysis in TLC, but in HPTLC you can perform the quantitative analysis by using the linearity. You can develop the linearity curve, and by that you can know the quantity present in unknown compound. Comparison of RF value with superimpose. So you can see the in HPTLC analysis we can compare the RF value and we can generate the superimposed spectra in HPTLC. Now this is the one more advancement is TLC MS. You can see here the instrument of ChemAC TLC MS, and there are many other options are available, but I am discussing here the TLC MS. You are just putting the spot on TLC of mixture and you are developing the TLC. After getting the separation, there are suppose three compounds are present in the mixture. So each compound's mass spectra you can get by this instrument. So you know this is the very important thing to generate the mass spectra, and from the mass spectra you can get the very good help in the structure elucidation. Structure interpretation, without mass spectra we cannot say anything. So if you have very less quantity or less quantity of mixture, at that time you can generate the mass spectra, you can perform the mass analysis from TLC MS instrument. Now we are going towards the paper chromatography. So paper chromatography is very basic technique, and all the BSc and MSc students are doing the practicals of paper chromatography in the lab during their semesters. And you can see the here ascending chromatography, circular chromatography, descending chromatography. So you can perform the separation on the paper and you can achieve the separation of mixture on the paper. Generally the all students are performing the separation of amino acid in the lab, and ninhydrin visualizing agent they are used. Now we are going towards the column chromatography. Column chromatography is very basic technique. In second slide we have seen that the botanists have used this technique to isolate the compound. In isolation from extract, this technique is very useful. You can use the isocratic and gradient elution. Means isocratic means you can use the single solvent system throughout the separation, while in gradient you can change the ratio of solvent system and you can perform the elution. So you can elute the fraction from column chromatography. Several fraction you can elute, and then you can do the perform the analysis of that particular fraction on thin layer chromatography. By that you can see the how many compounds are that present in particular fraction. So after the checking that particular fraction, you can see the your compounds is single spot or mixture. According to that you can apply another technique. Here I have loaded the natural product extract. So means phytochemical compound extract. Now we will apply the solvent system. You can see here very good images available of loaded the natural product extract. Now we are going towards the gas chromatography technique. This GC instrument is available in our RK University. Actually, this is the GC-MS instrument, and this is the combination of GC and MS. Means you can perform the separately GC analysis and GC-MS both analysis. When you are using the GC, at that time flame ionization detector will work, and when you are using the GCMS, at that time mass work as a detector. You can see in the slide how will you inject the sample in GC or GCMS. Here you can see this is the auto sampler. We can put the sample in GCMS. Now we are going towards the instrumentation of GC. So here is the carrier gas. You can use the most common gas is helium used in the carrier gas, and this is the flow controller. Then again sample injector, uh, going compound or mixture going towards the column and eluting from the column. This is the thermostatic oven. We can set the temperature of oven, and compound eluted compound detect by detector, and chromatogram will record here. So most common detectors are used in the GC is FID and TCD, thermal conductivity detector and flame ionization detector. Now you can see the mechanism of gas chromatography. You can see here the blue compound will elute first, that generate the blue peak here first, and red compound elute the later, and retention time is more compared to blue. So how the chromatogram generates, you can see here. Here the response is recorded by FID, and here you can see the retention time of compound, each compound. Okay, this is called chromatogram. When you are giving the mixture for the GC analysis, at that time you can get the spectra of gas chromatography. Here you can see this type of spectra you will get. Here the single peak is available, so you can say that single compound. But there is some impurity available, but you can consider as a single compound. And in the other spectra, you can see here the 1, 2 and 3 peaks are available. Means you can say the multiple compounds are available in the gas chromatography. Same here you also observe the 3 peaks are available. Now this is the only GC spectra, but when you are performing the GCMS analysis, at that time GC spectra you will get, but simultaneously you will get the mass spectra, and in mass spectra you will get the molecular weight of compound. See, GCMS is the highly powerful technique compared to all other chromatography technique, because the GCMS is the only technique will give you the identification of compound. So here you can see here the Hetria content compound is available. So directly you can get the result, directly you can identify the compound, but the condition is that the compound fragmentation pattern is available in the NIST library data. Nowadays, up to 10 lakh compound fragmentation patterns are available in the NIST library. So, if you are injecting the only one sample, just imagine you are injecting the 1 or 2 microliter of sample, and you can get the several compounds in one spectra with identification. So, this type of result you cannot get in any technique. So, as per my opinion, GCMS is the very good technique, and you can find the several research papers on the basis of only GCMS analysis. GCMS means this is the advanced version of GCMS. You here the dual MS detectors are available, and in GCMS there is a only single detector, while in GCMS dual detector. You can get the more sensitivity in this instrument compared to GCMS. So the you can get the dual confirmation because there are two mass detectors are available. So application, you can see here the identification of compound is the major application, and compared to this, no instrument will give you the result like GCMS. And other application is the quantitative analysis. You can also perform the quantitative analysis in case chromatography analysis. Now we are going towards the high performance liquid chromatography system, HPLC, and earlier it was called the high pressure liquid chromatography. We can use the pressure up to the 5000 psi pressure generated into the HPLC system. So here you can see the solvent reservoir. So here the mobile phase bottle we can see, and second is the degasser for removing the bubbles from the mobile phase. Solvent delivery system means pump will the deliver the solvent, means or mobile phase. Injector, auto injector is available, manual injector is available. There are two options for injector. Column and oven is here. Detectors will detect your compound or quantify the compound. Record, detector will send the data to the recorder. Here you can observe the auto sampler of HPLC. Now you can see on the screen, this is the manual injection in HPLC. If you have not auto sampler, you have to inject the sample manually. So there are many human error chances in the manual injection. So after the analysis, after the HPLC analysis, you will get the chromatogram. You can see here this is the this type of chromatogram you will get, and this is called peak area, this peak height, and retention time, peak width. So you can analyze the chromatogram with from whatever you get analysis of mixture. So if you say that this is the good chromatogram, so what is the poor chromatography? When you get the flat top peak, that is called poor chromatography. Peak shoulder and peak tailing, that is called the poor chromatography. However, sometimes you get the this type of broadness in the ahead of peak, means starting of peak. At that time it's called peak fronting, and you can uh, do the integration of chromatogram in any analysis, any HPLC analysis, in any LCMS analysis. You can do the correction in the HPLC analysis by integration. See, the integration is not recommended by any regulatory. In particular situation, you can do that, but integration should not recommended. Types of analysis: qualitative analysis. You can see the you all know that what is qualitative analysis. When how many compounds are present in your mixture, that is called the qualitative analysis. To detect the impurity and number of compounds in the mixture, that is called qualitative analysis. Means at that time you not require the how much or compound present in your mixture. So that type of analysis called qualitative analysis. Now you can see the quantitative analysis. You are quantifying the compound present in the mixture, and how you can quantify that compound? By with use of calibration curve or comparing the peak area of standard and sample. So you can quantify any compound in present in the mixture based on scale of operation. There are two types: analytical HPLC, where when we are doing the analysis, at that time we don't want the compound back, means recovery of sample is not possible. In the second type, preparative HPLC, you are doing the separation of mixture, and if you want the particular compound back, means you want to cut down that particular peak, and you want to separate that particular compound. At that time you have to perform the preparative HPA analysis. This technique is very costly, but you can get the very highly pure compound, and you can collect that fraction, and you can recover that compound. Here you can see the fraction is friction collected of your analysis. Whatever RT you want, that you can cut and collect the fractions. Detectors of HPLC. There are many detectors are available in HPLC. UV, PDA detector, refractive index detector, fluorescence detector, and mass detector. But UV, PDA detector and mass detector is the commonly you find in the pharma company, in any chemical company, in any research center. The, and other detectors are also used, but they have specific purpose. You can see in other detectors. In UV detectors works with UV light, measures the ability of solute to absorb light at particular wavelength. And you can see here the light enter into the enter slit, then grating, then exit slit, and pass from the fluid cell. And the result will detect by detectors, and that will forward towards the recorder. Here you can see the you are using the UV light for result purpose. So you can measure the quantity of compound with use of UV detector. Now PDA detector. You can operate the simultaneously absorbance of solute at several different wavelengths. That is called photodiode array detector, and this is the most common detector. You can use the deuterium lamp in this detector as a source. Fluorescence detector. Design of this detector is same as the fluorimeters, and this is the ideal detector for the compound which possess the molecular fluorescence. And this is the highly sensitive detectors, but sensitivity depends on fluorescence property of components in the eluate present. Next is the RI detector. The refractive index detector is a deflection type detector, and when your compound is not absorbing UV light, means UV inactive, do not fluoresce, and at that time you can use this type of detector. It responds to most of the solute like sugar, alcohol, fatty acid, polymer, organic compounds, anything. It measures the molecule's ability to deflect light in a flowing mobile phase in a flow cell. The amount of deflection is proportional to the concentration of solute in mobile phase. Mass detector, the very powerful detector of HPLC, and when it coupled with the HPLC coupled with the mass, it's called HPLC-MS. Means commonly it's called LC-MS, and this is widely used in pharmaceutical laboratories and R&D centers. Here is the LCMS. So many students are getting confused which technique is more important, GCMS, LCMS, GCMS-MS, LCMS-MS. So when you want to check the purity, at that time you have several techniques available, but selection of technique is more important. When you are synthesizing the compound, at that time your compound's molecular weight is less than 1000. At that time you should prefer the GCMS. You can get the purity and mass spectra both, but when your compound is having the molecular weight is up to 2000, means more than 1000 and up to 2000, at that time the LCMS technique most preferable technique, and Another thing is that if your compound having the higher boiling point, at that time you also prefer the LCMS technique. There is another advancement available in LCMS LCMS-MS. Here you can see the LCMS-MS of ABCIX. From this, here you can tune the compound, and here you can see that this is called the source, and these both are heaters, and this source you can see from the glass. The curtain plate is available, and from the and this is the capillary from HPLC to the compounds are going towards the mass. So the LCMS-MS is the highly useful in the bioanalytical department, and most of the CRO is using the different type of LCMS-MS, like thermo, ABSIX and waters instruments. So then they all instrument have a different sensitivity. You can use according to your requirement. ABSIX will give you the higher response and stability also, while waters give you the lower response but very good stability. So the again you are confusing the when the LCMS is useful for the up to the 2000 molecular weight compound. What we can do if the molecular weight is up to the 10,000? So at that time you should go for the multi-TOF technique. The multi-TOF is the soft ionization technique, and it is useful for the identification of molecular weight up to the 10,000. So again, you have a very diversity of technique, that is JCMS, LCMS, GCMS-MS, LCMS-MS, and multitop. So again, I want sometimes you require the higher resolution mass spectrometry. Means you require the confirmation up to the 4 decimal figure. At that time you should go for the HRMS analysis. The HRMS in with use of HRMS analysis you can get the more accurate molecular weight of compound. And the last technique is flash chromatography. You are developing the system in on the TLC. You are using the column chromatography for the separation. But at that time, when the single band is separating from the column, at that time, if you want to cut down that particular band, so you can do this in this technique, flash chromatography. You can cut down that particular band and collect the fractions. So this is all about the chromatography, and you all get the idea and the practical approach of chromatography. I think you can get the proper idea for your and proper technique depends on the quantity of your mixture. Now I want to share something about my group, my research group, and any faculty is incomplete without their students. You can see here my research group and my master student and my bachelor students. We are frequently organizing the webinar, a workshop and conferences at School of Science, RK University. You can see here the National Conference on Recent Innovation in Science and industrial talk by pharma leaders, hands-on workshop with UV, HPLC and GCMS. Most of the students near in the Gujarat region are benefiting by this workshop and conferences. You can see the Young Science Conclave. There are 33 colleges have participated in this Young Science Conclave, and many students are representing the RK University at global level for the working purpose and for the higher study. This is our School of Science team. Now we are going toward the question and answer slot. If you have any query, you can ask in the chat box section. And another thing, you can if you have any query, you can ask me in the mailbox jayesh.dhalani@rku.ac.in. Does one query is that does moisture have any reaction or it affects TLC plate since we have placed the TLC in open beaker. First thing is that you must not place the TLC in open beaker for development. And second thing is that the moisture always affect the TLC plate. Okay, and now we are going toward the next question, how to practically find the unretained component and unretained time. You can see you have to make a trial and error, proper combination of mobile phase. By that you can separate the mixture. This is the only option. How does one determine the most suitable mobile phase to separate to very close spot in DLC? So this is the main thing of solvent system designing. You can see the most of the separation is not most of the compound is or solvent system. First you find the how many spots are available in the how many spots are available in your mixture, then you can separate. So this is very difficult task in the case of natural product extract. You can find the near very minor distance between two spots. So at that time you have to take a many changes in your system, but that is only and only according to your mixture. Again, that is based on the trial and error system. There is no one get the dream of the solvent system. You can just imagine, you have to perform the list of experiment in the lab. Selection or of solvent can affect the RFW. Yes. What factor affects the RF value in TLC? Mainly the solvent system. What can be the preliminary test for the estimation of nature of sample, whether it is polar or non-polar, by which we can select type of mobile phase to be used? Sorry, I cannot getting the question. What can be the preliminary test for the estimation of nature of sample, whether it is polar or non-polar? Sorry, friend, I am not getting your question. What mode of chromatography would you recommend to using for the separation of polar, low molecular weight and non-volatile impurities? For non-volatile impurities, you should go for the HPLC. Does different concentration of substance give affect the chromatography? Yes. Sometimes you cannot get the spot on TLC where the compound having very less concentration, but at that time you can go for the hyphenated technique and you can get the better result. What happens if my sample solvent is stronger than my mobile phase? First thing, you friend, you have to soluble your sample in your mobile phase. There is the first primary criteria. Your sample is soluble in the mobile phase when you are using the mobile phase for the separation purpose. You cannot elute the mixture or the sample when your compound is not soluble in the mobile phase. Best book for chromatography techniques, you can find the Stahl thin layer chromatography is the very good for chromatography techniques, and phytochemical methods, that is also very good very good book for the separation of phytochemical compounds. You can identify the system. Can we separate radioactive substance using the not recommended to use the chromatography for radioactive compound. Okay, this is the last question, and if you have any query you can write mail to me, and I hope you all get the knowledge about the practical approach of chromatography. Thank you very much, and tomorrow we will send you the separate link. Okay, goodbye.